Hello everyone, this is Fahad Mirza and I welcome you to my channel. For the last few weeks, there is a new trend emerging in AI where the focus seems to be on PDF files and especially around retrieval of data from those PDF files. That data could be text, images, or any other tabular format which we could extract in as much accurate way as possible. You have seen me covering a lot of tool around that, Markdown, Docklink, and various other. Not only that, but also we have recently covered this ColPali model on the channel, where we installed it locally and then we tested it out on various benchmarks. In this video, I'm going to show you a process which you can use to fine tune this ColPali on your own custom dataset in order to have a customized, tailored document retrieval system. I will also be sharing the link to that notebook, so no need to copy paste. You can just simply sit back, relax, and watch it. If you don't know what ColPali is a document text query similarity model which is based on dual encoder architecture. The model is based on two models. First is PaliGemma, which is image encoder text decoder based image tower, and second one is the Gemma model, which is a decoder only text tower, where image and text outputs of each models are projected to a joint space. The similarity is calculated between the projected embeddings and documents, and texts are matched based on maximum similarity between them. This approach itself is as of now is state of the art for document retrieval, and that is what I'm going to show you by fine tuning this ColPali. And by the way, this ColPali model can be used for any application where you would like to build document retrieval pipeline, including multimodal RAG. Normally for document retrieval, you would transcribe a complex document using brittle PDF parsers that include image captioner, table to markdown readers, and OCR models. And that is where this ColPali can help, as it removes the need for such brittle and slow pipelines. But I believe that tools like Docklink come closer to it. But still, using ColPali removes the need for potentially complex and brittle layout recognition and OCR pipelines with a single model that can take into account both the textual and visual content. But of course, the downside is that you have to fine tune this ColPali on your own custom dataset, and that is what I'm going to show you in this video. Now, I am not going to run these commands, unfortunately, the reason being that I only have 48 GB of VRAM, courtesy mass compute, but this fine tuning requires around 80 GB of VRAM. So that is, I think, a big question mark on this one. I have even tried it out with QLoRa. Still, it just overflows more than 48 GB of VRAM. And if you don't know what fine tuning is, fine tuning a model simply means adjusting its existing parameters to better perform a specific task or adapt to a particular dataset. This process refines the model understanding and generates more accurate and relevant responses for the desired application. And if you look here, we are installing transformer, ColPali's engine, which is specific to this model, and PEFT. PEFT is parameter efficient fine tuning. It is a fine tuning technique that involves updating only a subset of model's parameters to adapt to new task or dataset. This approach reduces the computational cost and memory requirements of fine tuning, making it more efficient and scalable. And then we are installing some other libraries to optimize the fine tuning. For example, this bits and bytes is another wrapper on top of CUDA's custom function. And then after this is installed, we are logging into Hugging Face. You can, because these are the gated models. So, but I would suggest that if you're logging in, just go to huggingface.co, grab the right token if you're looking to also push the model to Hugging Face. Once you have logged in, all we are doing here is we are loading the model. As I said earlier, that you can use quantization with it. You can use 8-bit or 4-bit. Here they are using 4-bit quantization, but even with this 4-bit, it is going over 48 GB of VRAM. And then these are some of the libraries which we are importing. This is a ColPali model. It is going to be downloaded, and then some of the hyperparameters are being applied on top of it, and also we are specifying the low rank adaptation or LoRa configuration, that which layers we want to touch upon, which are the target ones, and then what sort of um, initialized LoRa weights which we are going to use, which is a Gaussian one, that's a bell shaped architecture. And then we are getting the model. So there you go, the model is downloaded and the shards have been loaded onto the GPU. And then this is a visual retriever we are getting from ColPali. This is the same thing which we did in this video. And by the way, if you are looking for hands-on stuff, where we have gone and installed this, watch this video which I just did 2 days ago. Anyway, and then you can grab your own data set, or you can just simply use this UFO ColPali data set. It's a very small data set by Daniel Van Strien which you can use anyway. So, and then they are dividing into training and testing subsets. This is a data set, how many rows and all that stuff. And this is where they are filtering out where there is no, where the text query column has no data. And then this is where you can just check out few of the data stuff. So this is the data which it looks like. And then you can simply use a collate function to create the document and queries out of it. This is just depends upon your data set, but it's always a good practice. And this is from here on, if you closely look, this is a very usual stuff around trainer, where we are specifying the trainer. These are some of the compute laws, prediction stop, with gradients and all that stuff. And all this is what it is doing. It is just creating this class, and then it is using these training arguments in order to start the training. For example, this is where the model will be placed. This is how many passes will be making on data set in order to fine tune the model. And then this is where we are optimizing the gradient, which is primarily the loss thing when it does a back propagation. And then these are logging step and some other standard values, if you look at it, which have been put in for this trainer. So once and this is for the observability if you want to do it. And then we are uh, instantiating this trainer. Once that's done, we are just starting the trainer here. It is going to train it, and then once it is trained, you can load and test tune the fine tune model by this. And from there, if you like, you can also push it to Hugging Face after testing. This is just a testing which is going on, and this is from here where you can push your own model to the Hugging Face. So fairly straightforward code. As I said, I will drop the link to this in video's description. I think the only thing is that it takes a lot of VRAM. Hopefully in the future that is going to improve, but this is the lay of the land at the moment. Anyway, if you're looking to fine tune this ColPali on your own data set, try it out. Let me know what do you think. And if you want to learn more about its architecture, watch this video. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.